Hello everybody. So, today's lecture is going to be on Module 030105G, also known as Installation of Electrical Equipment. Now, most of this lecture is going to be about Section 26, which Section 26 is Installation of Electrical Equipment. And Section 64 is, or what we're going to look at in Section 64, is batteries. So let's look at batteries sort of briefly in Section 64, and then we'll move on to Section 26. So in Section 64, I'm on page 370. Section 64 has the installation of batteries. Now, the reason that installation of batteries is in Section 64 and not 26 is because Section 64, I don't know if you can see it on the camera here, but you can flip to the front of Section 64 in your codebook if you'd like. But Section 64 is on renewable energy systems, energy production systems, and energy storage systems. And so all three of those phrases or things are sort of related to batteries, especially energy storage systems. So batteries, and the large batteries that electricians install, we're going to need to concern ourselves with temperature, especially anything outside of extreme ranges, because if you remember a couple years ago, I think it was pretty recent in reference to the time of this lecture, but recently Samsung Galaxy Note 7 cell phones were exploding because the batteries were overheating, making the whole phone overheat and melt or explode in people's ears, all kinds of nasty things. Now, the batteries that electricians install are generally larger than a battery that powers a cell phone. And batteries are great ways to have backup power or to store energy, but we need to worry about ventilating the rooms or areas where we put batteries, because too hot or too cold could cause problems. Too hot of a battery could, like the Samsung phone example, too hot of a battery could make the battery explode or melt. Too cold of a battery would make the battery not function very well, which is also bad. Now, there are some, there's a couple rules. There's not many rules for installation of batteries. I think it's just a couple pages here. One thing that you'll see in other areas of the code book, but it's also here, so I thought I'd mention it, is it talks about, in 64804 subrule 2, batteries with exposed energized parts shall be kept in a room or enclosure accessible only to authorized personnel, which makes sense. If we have exposed electrical terminals, we don't want just anybody to walk by and be hurt by them. When it says authorized personnel, you could also think that as person with keys. So an electrician who's, authorized to work in an area, and that area has batteries, in this example, that electrician would be an authorized personnel. But maintenance people that check on these batteries and other such things in these rooms, they're also authorized personnel. They're allowed to be in there to work on these things. So that's one way to think about authorized personnel. They talk about fine strand connections for batteries. I'm not going to go over too much of batteries, but just to drive home that temperature thing, let's go check out Appendix B. So in Appendix B here for 64802, page 694 in your code books, the freezing point of the electrolyte used in a lead acid battery is minus 15 degrees Celsius or negative 15 Celsius with a specific gravity. So if we don't know exactly what that means, the range of minus 15 to minus 20, minus 15 to minus 27 is where a lead acid battery could freeze. It's higher, as it says here, when the battery is discharged. So if the battery is close to empty or empty, if it has almost 0 volts, it's more likely to freeze. And it says here afterwards, batteries should not be located in areas where the temperature is likely to fall below -7. So if you want to think of a very practical example that may affect all of us come the winter time in Canada, this is kind of why you plug in your block heater, because you don't want your battery to freeze. You want the components of the engine. You don't want the battery to freeze. You don't want lots of stuff to freeze for your car, for the engine, for the compartment. So plug in your block heater because your car battery is most likely lead acid. And you don't want lead acid to get below these temperatures, which certainly happens if you exist in Canada in the wintertime. Now this diagram in your module is a good one. It's got these measurements, and you can go through that area in section 64 and find the rules that tell you exactly what these mean, or the rules that tell us to do these things. But just to relate this diagram back to theory, what type of circuit would we say this is? So we're connected here, we go out into the next one, out into the next one. This looks to me like a series circuit. And so what we could say is if each of these batteries was, for example, a 12-volt DC battery, 12 volt plus 12 volt plus 12 volt, between these two lines, we would get 36 volts DC, because these are each voltage rises. So just wanted to relate back to the theory component while we're doing code, because everything's kind of related in the course. So if you can relate the different subjects, that may help your learning. Now before we get into section 26, page 10 of your module has, I guess, a typo or what have you. This should be figure B26-3. And we'll look at these figures in a little bit, but basically that part of your code book, that part of your module is referring to this diagram in your code book, or this figure 26-3, not the figure on the previous page 26-2. And we'll look at both of those figures, but I just wanted to mention that correction in your module before we got too far into section 26. So we're going to start a ways back into section 26. We're going to start at 26,700, and most of the module in this lecture are going to be centered around receptacles and where can we put them and where are they required and protections of them, so on and so forth. So if we're going to be putting these receptacles everywhere, let's go check out diagram 1, and let's see the configurations. So basically the receptacles we commonly install are going to fit what these diagrams say they should be. Now you can have specific receptacles and ones that are created specifically for a piece of equipment, but in general the receptacles we install are going to be in diagram 1. So diagram 1 is page 530 in your code book, and you'll see that I've kind of highlighted a couple significant ones or very common receptacles. Now this is standard or just the regular receptacle. These are probably the ones you will install the most. 520R is a 20 amp receptacle. Now it's not specific to kitchens, but that's the most common place that we see them, and you might see them in your house on your kitchen counter. The receptacles on your kitchen counter might have this little T for the identified terminal. And then our dryer and range receptacle. And if you want to try to remember which is which, aside from them being a 1430R, which the 30 would be 30 amps for your dryer, and the 50R being 50 amps for your range. The little L here for the identified terminal is sometimes referred to as the L for laundry for your dryer receptacle. That's always how I've remembered it, but that's just a little fun thing to do if you like having fun with the code book. Now, down below here, the note is going to lay out, W represents the identified terminal, which we can see here, and that's the one I just pointed out for the dryer receptacle. X, Y, Z are for the ungrounded conductors. And so some of these receptacles don't have an identified terminal. And so for a 250 volt, 15 amp receptacle, which I know that a 615R is rated for 15 amps because it's under that column. And so a 615R does not have an identified terminal. So from this terminal to this terminal, we would get 240 volts. Now it's rated for 250. So since it's rated for 250, that's just kind of some extra insurance to make sure that nothing bad happens to this receptacle when we give it 240 or 241, 242, what have you. The 520A, the alternate for the if we want to call that our kitchen counter receptacle, the 520A has this odd looking slot. It's a little bit phased out because a lot of appliances that you would use in your kitchen will have basically a cord end, a male cord end, that would fit a 515R or a 520R. And we'll look at the ways that you can use either one for your kitchen counter a little bit later when we start putting receptacles into the kitchen. And if you notice the voltage rating on the side here, 125, that's going to come up, and we have to make sure that we don't put too much voltage on these receptacles, but that's going to come up when we do the kitchen counter receptacles as well. Now back to section 14 for a second, talking about protection and control, and 14600 is under the protection and control of miscellaneous apparatus subheading. And 14600 states, receptacles shall not be connected to a branch circuit having overcurrent protection rated or set at more than the ampere rating of the receptacle, except as permitted by other sections of this code. So you can't put a 15 amp receptacle on a 20 amp circuit. You can put a 20 amp receptacle on a 15 amp circuit. In general, you wouldn't do that because the 20 amp receptacle is probably more expensive. If you look back to diagram 1, that 520A alternate receptacle, the way that one's designed, it wouldn't fit most appliances and things you would plug into a 15 amp receptacle. But we're going to look at a rule in section 26 that basically tells us to use a rated receptacle on the circuit that matches the rating. And we've kind of come full circle here. We're back to 26700, subrule 2, except as provided by other rules of this code. So once again, when it says except, or it starts off the subrule as except, I'm just going to ignore that line. I'm just going to block that out in my mind. You can skip that. Reading this one, you might go, oh, okay, well, other rules of this code, whatever. So let's just ignore that for a second. 26700, subrule 2, receptacles having configurations in accordance with diagrams 1 and 2. Now, we didn't really look at diagrams 2. Diagram 2 is for locking receptacles, which is basically if you plug something in, you twist the cable, the male end of that receptacle. You plug it in and twist it, and then it's hard. Basically, it won't come out easily. You'd have to untwist it and then pull the receptacle or the the cable out of the receptacle. So that's diagram 2. But all the same, in accordance with diagrams 1, shall be connected only to circuits having a nominal system voltage and ampere rating corresponding to the rating of the configurations. So that's why I was just saying that we'll just match the circuit rating to the receptacle, or the receptacle will match the circuit rating. 14600 tells us you can't, put too much current or above rated amperage on a receptacle or a device. And then this is telling us just match it. So can you put a 20 amp receptacle on a 15 amp circuit? Sort of, maybe, but 26700 is saying, in general, no, just don't do that. Just get the right receptacle. 15 amp receptacle is not too expensive anyways. Now, turning over the page to 26704, this is going to tell us what shall be GFCI protected. This is going to tell us the protection of receptacles by a ground fault circuit interrupter of the Class A type. Now, if you go to your bathroom, aside from very old houses and maybe old hotel rooms, you're going to have a GFCI receptacle. Most likely, it's the most common way to protect that receptacle with a GFCI that needs GFCI protection. You're going to have a GFCI receptacle in your bathroom. And if you have an outdoor receptacle, it might also be, it's most likely also a GFCI receptacle. Now, if you've ever installed them or looked at them, in our lab class, you can look at an example of one. They have a line side and a load side on the receptacle. And basically how that works is if we need a receptacle to be protected or have GFCI protection on, and we're not going to use, let's say for example, we're not using a circuit breaker. The way we can do that is by using what's called the line side and the load side of a receptacle. So let's say this is a Decora receptacle, a duplex. The line side, now it should be labeled, but most of the time the line side is on the top. Now, double check that in case I'm wrong. You don't want to mess that up. Because the load side, everything that's on these wires after the load side are going to be GFCI protected. So we'll have our identified wires and live wires come in on either of these terminals of the receptacle. And so if this is in some kind of box, we bring our feed from the panel. We bring a 2-wire feed into here. Our white wire is going to go to the identified side, and our black wire would probably go to that side. And then we could take 2 cables to another receptacle. And from that cable, we have our identified as well as our live wire. Everything on this cable is now GFCI protected because it's on the load side of this GFCI receptacle. And we'll just label it like that. On this side, the feed from the panel, it's not GFCI protected. So now you can usually only put so many receptacles on, like after this guy on the load side of this protection. But if you have 2 receptacles outside, you see one is GFCI, the other one's not. When this guy trips, this one would lose power because it's intended to protect downstream. So that's another terminology we can look at with this. This receptacle would be the upstream receptacle from everything down here. This is downstream because it's on the load side. So that's just kind of a quick diagram to talk about some of this GFCI protection and how we do it. And when we're talking about GFCI protection, usually we're talking about receptacles near sources of water, for example, outdoors, rain, snow, what have you, or wash basins complete with a drain pipe, bathtubs, shower stalls, maybe kitchen sinks, bathroom sinks, those types of things. Now moving on down to tamper-resistant receptacles, or what I say to myself when I think about this rule is, think about the children. Oh God, oh no, the danger, please think about the children. And I say that silly thing because tamper-resistant receptacles are mostly intended to protect children. That's basically what they're for. They make it difficult for kids to electrocute themselves with a receptacle. And so, in general, if you're thinking, where do I put tamper-resistant receptacles? Well, you're going to install those types in places where children will be, such as child care facilities. So a daycare, yep, there's going to be kids there. Guest rooms and suites of hotels and motels, yep, definitely could be kids in hotels and motels. Preschools and elementary education facilities, totally. And dwelling units. Now, subrule 2 is telling us if there's a dedicated or receptacle for a dedicated stationary appliance, such as a stove or a refrigerator, or if it's above 2 meters from the floor, you don't need a tamper-resistant receptacle. Because if there's a kid that can move a fridge by themselves or can reach a receptacle that's 2 meters off the floor, probably call the Guinness Book of World Records or somebody, because that is an anomaly of a child. So we don't need to make those tamper resistant, because that's probably not going to happen. We're not going to come across those kids. But what we could call a tamper resistant receptacle, if we want to relate back to or use some safety terminology, this would be an engineered solution to a safety problem. So somebody designed the tamper-resistant receptacle to solve a problem, to make it more safe. So instead of telling kids, hey, don't stick a penny in the socket, we just designed something that makes it far, far more difficult for a kid to electrocute themselves. So let's start to put some of these receptacles places. And let's start looking at what requirements, or what's the minimum number of receptacles and protection and so on and so forth that we will need in houses, in dwelling units, in residences. Let's start in the garage. This one's sort of a simple rule for how many receptacles to start with. And your module breaks down with these diagrams really well. It breaks down where to put them and some of the rules. But I want to look at the rules specifically and talk about them, because some of these spacings and what goes where can get a little confusing. It's a little overwhelming at first. So let's start with a very straightforward one of, we have 2 receptacles. So I know, based on code, that this is a 2-car garage. And I know that because 26.724 B, item B, tells me receptacles for single dwellings. So a single dwelling is where you'll find garages in general. At least one duplex receptacle readily accessible from floor or grade level shall be provided for each car space in a garage or carport of a single dwelling. So that's probably, since this is the Canadian electrical code, that's probably for your block heater, to make sure you have that. Now, we gotta know, do these receptacles need to be tamper resistant, AFCI, GFCI protected? You know, you might say, what the heck is AFCI? So everything aside from those exceptions for tamper resistant have to be tamper resistant. So that one's a little bit straightforward. You could install these receptacles 2 meters above the floor, and maybe that works, sure. But whether or not these need to be GFCI protected or AFCI protected could get a little confusing. Now, in general, to make it GFCI protected, or whether or not it needs to be GFCI protected, we just look at 26704, and that just tells us, yeah, these things need GFCI protection. But for AFCI, it's going to tell us that each branch circuit supplying 125 volt receptacles rated 20 amps or less. So most of the receptacles in our house are going to be 15 or 20 amps, aside from the range and dryer receptacles. So each branch circuit supplying those types of receptacles shall be provided with arc fault protection by a combination type arc fault circuit interrupter, or an AFCI breaker, except for branch circuits supplying receptacles installed in accordance with 26720F, 26722 DI, III, IV, and V, or Rule 26722 item D, items 1, 3, 4, and 5. Now, go look at these to see why I wrote exactly this beside these exceptions. It's basically to save myself some time, because when you look at these rules are talking about the bathroom GFCI, provided that no other receptacles are connected to these circuits, or your fridge, your kitchen counter, your island, your peninsula, or your kitchen peninsula, and your sump pump. So those are the only things that don't need to be AFCI protected. Now, one way we can do it is using an AFCI breaker. That's fine. Subrule 2 says, notwithstanding Subrule 1, the entire branch circuit need not be provided with arc fault protection where, now this is a little bit misleading. This is saying you don't need AFCI where you use AFCI in a different way. So Subrule 2 is telling us if you don't have an AFCI breaker, you can also do it these two ways. And we're going to go look at a demo board that's at RDP, and that'll explain these 3 types of ways that we use AFCI protection. So to give ourselves AFCI protection for Rule 26658, we're going to have 3 ways to do it. Way number 1, which is Subrule 1, is the code book just says, yeah, use an AFCI breaker. Then you're good. And if we're using an AFCI breaker, we use non-metallic sheathed cable, or you're allowed to use non-metallic sheathed cable from the panel to the receptacles, wherever they may be, whichever ones need to be AFCI protected. If we are not going to use an AFCI circuit breaker, then we're going to go to Subrule 2, which states if we're not going to do that, we have to give mechanical protection from the panel to basically the point of AFCI protection. Either an AFCI receptacle, which has a line side and a load side, similar to that GFCI drawing I did, or we could use an AFCI dead front, called a dead front, sort of. I don't know if that's a technical term or a field term, but either way, it doesn't have any use in the front other than this AFCI protection. So mechanical protection, this is using AC90. You could use conduit as well, or some other means of protection basically. But from the panel, so we'd use a regular circuit breaker. From the panel, we have AC90 going to an AFCI receptacle, which goes to the line side, and then the load side is non-metallic sheathed cable. And that's how we satisfy subrule 2 if we don't want to buy the sometimes expensive AFCI breaker. So with the garage covered, and with our AFCI demonstration there by, yours truly, we're going to go outside now, and we're going to look at the rules that say, put one thing outside, and oh yeah, GFCI protect it, and oh yeah, AFCI protect it. So you might use an AFCI breaker in this scenario, which would then protect the GFCI receptacle. And the reason I know all those things is because, well, in simple terms, the code book tells me, but 26724A says for each single dwelling, at least one duplex receptacle shall be installed outdoors, so it's readily accessible from the ground or grade level. So if it has to be, close to grade or ground level, and 26704 tells me all receptacles that are, 15R or 20R outdoors within 2.5 meters of finished grade shall be GFCI protected, or shall be protected with a ground fault circuit interrupter of the Class A type. And if that outdoor receptacle has to be readily accessible, it probably needs to be 2.5 meters, or at least, probably less than 2.5 meters above finished grade. And the reason I know it's AFCI protected as well is because it does not fit into this very limited range of exclusions. So that's going to cover our outside or outdoor receptacle. Now we're going to look at the rule first, and then we're going to look at the picture or the diagram. Hopefully it explains the rule. I'm looking at 26722E, which states no point in a hallway within a dwelling unit shall be more than 4.5 meters from a duplex receptacle as measured by the shortest path that the supply cord of an appliance connected to the receptacle would follow without passing through an opening fitted with a door. Okay, so the important thing for us for placing receptacles in this dwelling is that no point in a hallway shall be more than 4.5 meters. Now, that means we would put a receptacle every 9 meters, which might sound very strange, but just stay with me. Let's go back to our picture here. So this receptacle, which is going to be AFCI protected, yep, it's not one of the exceptions, so that's going to be AFCI protected. No point in this hallway can be greater than 4.5 meters measured along the floor line, or measured on the floor line along the wall, however you want to think about it. So along this wall, we cannot be more than 4.5 meters from a receptacle. So the reason I said if it was, we can do a receptacle every 9 meters is so we can assume this hallway is 9 meters because 4.5 plus 4.5 is 9. And why I keep saying that 9 meters is if we had a hallway that was, let's say, 12 meters, we would have one receptacle here and one here. We know we need 2 because from this point we could go 4.5 meters, and from here we would go 4.5 meters. So if I had, let's say for example, a vacuum cleaner, which usually has a cord that's about 4.5 meters if it's a residential vacuum cleaner. And if I'm cleaning this hallway, I need that cord to reach a receptacle so that the vacuum cleaner will work. That's an example. Now, once again, no point shall be more than 4.5 meters. So if I'm standing here, from this point to this receptacle, can't be more than 4.5 meters. And from here to this receptacle, I can't be more than 4.5 meters. Now, if I'm standing here, I got this receptacle. If I'm standing here, I have this guy. So that's got me covered. But since no point can be more than 4.5 meters, if I stand here, this one's got me covered, this one's got me covered. Between the receptacles, my distance would be 9 meters. So that's why I was saying in a hallway, we would put a receptacle every 9 meters. Even though we still can't be more than 4.5 meters from a receptacle. So if your hallway was 9.1 meters, then you would just know that you need 2 receptacles. Because then you would find a point that one receptacle wouldn't cover. But since we're told here that this is 4.5 meters and this is 4.5 meters, or it's just telling us that's our maximum, we only need 1 receptacle in this hallway. Now this type of, 4.5, 4.5, so 9 between them, this type of laying out of receptacles comes up when we do bedroom receptacles or just general area receptacles, and when we do kitchen counter receptacles. Now the other side of the hallway has this door interrupting this wall space, and so it looks like we're going to use this receptacle to cover our 4.5 meters. Okay, cool. Maybe that helps us to beat a code. So that's our hallway. So we got the garage covered, outside, hallway. Now let's move into some of this spacing and laying out of receptacles in the bedroom. Now for these general area receptacles, we're going to start to talk about usable wall space. And the code book, it's got you covered, as it sometimes does, usually does. It tries to. Usable wall space, referred to in item A, which we're going to look at, shall include a wall space 900 millimeters or more in width, but shall not include doorways, areas occupied by a door when fully opened, windows that extend to the floor, fireplaces, or other permanent installations that would limit the use of the wall space, hence usable wall space. So when we look at item A, once again it's messing up by starting with except, so let's jump over that. So item A, in dwelling units, duplex receptacles shall be installed in the finished walls of every room or area other than bathrooms, hallways, laundry rooms, water closet rooms, utility rooms, or closets, so that no point along the floor line of any usable wall space is more than 1.8 meters horizontally from a receptacle in that or an adjoining space, such distance being measured along the floor line of the wall space involved, or spaces involved. So what item A is saying, and we'll look at item C as well here. Item A is saying you can't have a point along this wall, in a bedroom is the type of wall we're talking about, Also, this dining area we're going to look at is one of these general receptacles, is what I like to call them when we're talking about item A. So once again, this is usable wall space. This would also be usable wall space, as it says it's 900 millimeters or more. We're not going to put receptacles in closets, and we're not going to put them on, a wall where the window extends to the floor. Don't try to put a receptacle in the window. That's not going to work. Now, if the window doesn't go to the floor, then we could put a receptacle under it, maybe. And if this window didn't go to the floor, maybe we would have a receptacle somewhere here because we would have more usable wall space. But because the usable wall space is broken up from here to here by this window that goes to the floor, this is not usable wall space. It's less than 900 millimeters. And so if I picked a point between these two receptacles that are drawn on here, and I was 1.8 meters from this one and 1.8 meters measured along the floor line horizontally, I could be 3.6 meters between receptacles. And when this door opens, if we could label the door swing, the space behind the door, or the space where the door would be when it's open, would not be considered usable wall space. So if you had to measure from this window to, where the usable wall space ends, you would just take a measurement of this door and apply it from, the door frame up until where that measurement stops. And you would say, yeah, when that door's open, which, maybe you leave it open all the time, that's not usable wall space. So let's move into this bathroom laundry combination area. Now our dryer receptacle is 240 volt, so it's going to take up 2 circuits. It's going to be a 2-pole breaker. That doesn't need to be AFCI protected because, if you remember, our AFCI protection is about 15 and 20 amp receptacles. The washer, on the other hand, does need to be AFCI protected. It's not one of the exceptions. The washing machine receptacle, however, or the receptacle for the clothes washer, however you want to put it, it does not need to be tamper resistant, though, because there's going to be a washing machine in front of it. So this is a stationary appliance. Once again, if a kid can move a washing machine to get to that receptacle, that kid is a frickin' superhuman. Okay? We need him fighting crime or whatever superhumans actually do. Now, let's go look at the requirement for this, because it's going to make us put this close enough to the sink that it has to be GFCI protected. So first things for that receptacle in the bathroom. Receptacles having this configuration installed within 1.5 meters of sinks, bathtubs, shower stalls shall be protected by a GFCI. Okay, so within 1.5 meters. Now, 26.720, skipped it. F says that one receptacle shall be installed in each bathroom and washroom within a wash basin and shall be located within 1 meter of any one wash basin. So this sink is a wash basin. This has to be within 1 meter. But since it's within 1 meter, it has to be GFCI protected because GFCI protection is within 1.5 meters. Now it goes on in item G to say, receptacles in bathrooms shall, where practicable, be located at least 1 meter, but in no case less than 500 millimeters from the bathtub or shower stall, this distance being measured horizontally between the receptacle and the bathtub or shower stall without piercing a wall, partition, or similar obstacle. So we will make this receptacle GFCI protected, but we still don't want someone to be able to reach out, if someone's in here showering, doing whatever they do in the tub, we still don't want them to be able to reach a receptacle, because when they're in a shower stall, they're probably going to be wet. Most of the time. That's what you do when you spend your time in a shower stall. I mean, that's what I do, at least. If people are doing weird stuff, that's, or not weird, but other stuff, that's up to them. But, aside from this lecture going way off the rails, we can't have this receptacle within 500 millimeters of this shower stall, even though it's GFCI protected. All right? 26720 E, since we're kind of in the area of laundry rooms, if you have a space where the complete plumbing is installed to accommodate a washing machine, we're going to have at least one duplex receptacle. We'll also have one in each utility room, in an unfinished basement, and in each laundry room, in addition to any receptacle specified in item I. So you need an extra. If this was just a laundry room and there was nothing else in this room, we would need a receptacle for the washer and an extra receptacle. Now, since this is in a bathroom, this, bathroom sink or this bathroom GFCI receptacle counts towards that item, the extra receptacle item. So that's just kind of a bit of an odd diagram for that rule, but that's one thing you might run into. So now for the kitchen, and I wanted to talk about this split receptacle, which is protected by a 2-pole GFCI circuit breaker because it's within so much distance of a sink. Now, the reason the split receptacle is protected by a 2-pole GFCI circuit breaker is because and we'll look at the rule that says you can use this for your kitchen counter receptacles, which is a specific type of receptacle in a dwelling. But when we use a split receptacle, what we mean by that is we're going to break this little tab in between our two live terminals. And we're going to use a 2-pole breaker. So the top half of this receptacle is one circuit, and the bottom half is the other circuit. Now, you don't break the tab on the identified side, or the side where your white wire goes. That's fine. We want that to just be continuous. We want both of those to have the same identified or common path back to our panel. I was calling this identified. That's actually a mistake, because that would be the neutral, because now we have a 3-wire coming to here. So my apologies. That would be a neutral, not the identified, because we have 2 live wires. Now, an important thing to note, very important, these types of split receptacles are, in my experience, not the common way to install kitchen counter receptacles, but all the same, we have a 2-pole breaker. We have 2 different circuits at one duplex receptacle. We have, much like our dryer and range, 240 volts between these conductors. But you may not be able to see it here, but if you look at diagram 1, it tells me that this type of receptacle is rated for 125 volts. So if I don't break this tab, I probably just did a line-to-line short, right? I got two circuits touching together. I just gave this receptacle, which is rated for 125, 240 volts. That could be bad. So if someone's going to do this, you have to make sure that you break that tab between the screws on the live side or on the side where you're going to put your ungrounded conductors of the receptacle. So the more common way to do it, instead of breaking tabs and using a 2-pole GFCI circuit breaker, which is kind of expensive, we use, or it's more common to use, a 20 amp receptacle, and you can just use a GFCI receptacle. Now you can use two of them, sure. And section 26 says you can use 2 receptacles per circuit for a kitchen counter. And we'll look at that in a second here. But a GFCI receptacle, which you could put this one on the load side of this GFCI receptacle, that might work. But all the same, this is much cheaper than a 2-pole GFCI breaker, in my experience. If things change, then maybe people wire kitchens differently, but that is why we use 20 amp receptacles. And the whole purpose why these are even a different, why we want 2 15 amp circuits at one receptacle or 20 amp circuit at a receptacle is if you plug in a blender and a toaster, maybe you want both to run at the same time. You're making a smoothie while you're toasting bread. I don't know. But because there was nuisance tripping in the past, the codebook adapted and said, okay, for your kitchen counter, because you have these large appliances that may be operating at the same time, you can only do 2 receptacles per circuit, and they need to have a larger ampacity or more power. So we do that with either split receptacles or 20 amp circuits. So 26722 is what's going to tell me in your kitchen or in dwelling units that shall be installed in each kitchen. We're going to have one receptacle for the refrigerator, and that's going to be a dedicated circuit. Check that out in a second. We also need a sufficient number of receptacles, so 515R split or 520R, so either 2 15 amp circuits per receptacle or one 20 amp circuit for 2 receptacles. Along the wall at counter work surfaces, excluding sinks, built-in equipment, isolated work surfaces, less than 300 millimeters. Along at the wall line, so that no point along the wall is more than 900 millimeters from a receptacle measured horizontally along the wall line. So, once again, we have that no point along the wall type of measurement. And so if no point can be more than 900 millimeters maximum between receptacles, we could have 1.8 meters. Now we can't have receptacles behind the sink. So that's non-usable work area. But since we have 900 millimeters here, we need to have a receptacle. And since this is an isolated work area, more than 300 millimeters, now we have a receptacle here. And we're going to have 2 per circuit. And so we could put these 2 together, since neither one of these need to be GFCI protected, and we could put these 2 together. Now, this drawing, or this symbol, is for a 520R receptacle with a little tab sticking out there. This would be a split receptacle, this symbol. And so there's 2 circuits for these 2 receptacles, right? Because we're going to break that tab on the live side. So in terms of, how many receptacles per circuit, 26722D345, which is what I was just talking about, No more than 2 receptacles shall be connected to a branch circuit, and no other receptacles shall be connected to these circuits. Now, there is an exception to that right below it, item E, which says, if you only have one receptacle based on your measurements, you only need one branch circuit, okay? And also, notwithstanding DI, which is no more than 2 receptacles per branch circuit, this is going to talk about receptacles on the front of counters for disability access. So if you're in a wheelchair and this receptacle is back on the wall, especially this one, you got to reach across the corner. If you're in a wheelchair, you might not be able to use that receptacle. So the code is saying, okay, you can put one at the front here and one at the front here, and then you would technically have 4 receptacles for that circuit, but it's assuming that if you're putting in these disability receptacles, someone's not using all 4 at the same time. And how that looks is 26720D, where receptacles, these split or the 20 amp, are installed on the side of a counter workspace in a kitchen designed for use by persons with disabilities. Such receptacles, shall not be considered as substituting for the receptacles required by Subrule 722D. So you still have to put in your counter receptacles, but it's telling you, if you need to compensate for someone with a disability, you can put them on the same circuit. And so 26654, just want to look at some of this kind of, to me at least, famously weird situation for branch circuits. Now, we know that the range and dryer are going to be their own dedicated circuit. Dedicated branch circuit, that is. Your refrigerator is also a dedicated branch circuit, except, let's read here on item A, receptacles installed for refrigerators in accordance with 26722DI, which is saying, put one in for a receptacle for a refrigerator, shall be supplied by at least one branch circuit that does not supply any other outlets. That makes sense. You don't want to overload that circuit that powers your fridge. Except a recessed clock receptacle intended for use with an electric clock. So, what the heck is that talking about? This symbol is a single outlet, basically, right? We have duplex receptacles and let's call that singlex receptacles or whatever. The name's escaping me at the moment. But what that branch circuit rule means, 26654A, is this circuit can have a clock receptacle on with it. And that clock receptacle should just only have a clock plugged into it. Now, the benefit of that and the reasoning for that could be, or I believe it is, if your fridge overloads the circuit or that circuit turns off, your clock receptacle would also lose power, which means your clock would stop. Unless it has battery backup, which would defeat the whole purpose. But if your clock has battery backup, I don't know why you're plugging it in. So let's say you're away from the kitchen or the house and you don't know that the refrigerator has lost power. That clock receptacle, it would lose power at the same time, and it would tell you the time that your refrigerator lost power. Now, hopefully you see that clock stopped within 12 hours, because otherwise that might throw you off. But all the same, that's going to notify you that, hey, this doesn't have power and your food's going to spoil. So that's the only receptacle that's allowed to be on your refrigerator circuit. And just to once again say, yeah, your range is circuit 9 and 10. That's a 2-pole breaker because that's going to be a 240 volt receptacle. Now the rest of, just the general receptacles, this is that dining area. These are just, 3.6 meters between them, usable wall space. There's nothing on these walls when the place is built. These need to be AFCI protected. And those will be the only ones that need to be AFCI protected in this kitchen, the way this kitchen is set up. And so the last thing to look at for this lecture, there's a lot of back and forth in the 600 and 700 area of this code book, or those rules for receptacles and branch circuits for dwellings. The more practice you have, the more familiar you will get with it. But the last thing to look at is this section on heating equipment. And specifically for our dwelling, we're going to think about the furnace. That's our primary source of heat in, Canada and Alberta. And the mechanical protection of the cable. So cables for all branch circuit or tap conductors within 1.5 meters from the floor shall be adequately protected from mechanical damage. So in Canada, it's really important that our heating equipment, especially where people live, it's important that that heating equipment works. So we're going to add a little extra protection for the cables that feed those heating equipment. Now, the big thing to sort of focus on or understand for heating equipment is not only do we need to protect that cable, so basically you're going to use AC 90 for the cable that's within 1.5 meters from the floor. And if you live in a house, go look at your furnace. There better damn well be AC 90 feeding that furnace. It should not be NMD 90. And the disconnecting means, so some kind of switching mechanism to turn off the furnace or the heating equipment, but we're going to talk about a furnace because we're talking about a dwelling. The disconnecting means shall be permitted to be a branch circuit breaker at the distribution panel board, provided that the panel board is located between, so you see highlighted, underlined, between the furnace and the point of entry to the area where the furnace is located. And where a separate switch is required due to the unsuitable location of the branch circuit breaker, it shall not be located on the furnace, nor in a location that can be reached only by passing close to the furnace, and it has to be marked to indicate the equipment it controls. So what that means, and your module has a perfect picture for it, if when I walk into my utility room, or I'm just in an unfinished basement, if when I walk in there, the panel is between where I come in and the furnace, that's good. I can use the breaker as my disconnecting means. But if the panel board is not between where I come in and the furnace, I need a separate switch. Now, this separate switch is pretty common because usually what happens is you run NMD from the panel over to the ceiling space above the furnace, and then you put a switch either high up on the wall, so you can't just brush the switch with your shoulder when you walk past the switch, or you might put it up in the ceiling and then come down with AC 90 to feed the furnace. Because 26802 is saying within 1.5 meters of the floor it shall be adequately protected from mechanical damage. We can do that with AC 90. And to avoid the accidental turn off, you can put it on the ceiling, maybe. Some people would say you can't because that's not accessible. Or you put the switch, this disconnecting switch, up high so that someone doesn't think it's a light switch. Like for this example, if someone's leaving this room, if there's a light switch here for this utility room, and this furnace switch was down at the same height, they might hit the furnace switch by accident, turn off their furnace, leave the room. Maybe they leave their house. Their house might freeze. So you got to put that switch somewhere that it's obvious, that it's labeled, hey, on the furnace disconnecting means it's not easy to turn it off. All those kind of rules under sub-rule 6 and 7. And so that's going to be about it for this module. And as always, send me questions if you have them.